All right, so we are going to start talking about the polar coordinate system, which should be a brand new topic for you, so not something you've ever learned before. And so it's a whole new coordinate system that's based on circles. And before, with the Cartesian coordinate system, everything is based on rectangles. So it would be like if someone gives you directions and you go down one street, make a 90-degree angle, go down another street, and end up at your location. The polar coordinate system takes you straight to your location. They tell you how far to go and the angle to take, like what direction to take. So it's just a different way to get to the same place. All right, so the origin in the polar coordinate system is called the pole. And the horizontal axis in the positive direction is called the polar axis. All right. And polar coordinates are made up of r and theta. So instead of x and y, you have r and theta. And r is the directed distance. So this is like if someone tells you how far you have to go. And theta is the directed angle, so it tells you the angle to take. Now, a positive angle is going to take you in a counterclockwise direction, and then there are going to be instances where we have negative angles. They are going to rotate in the clockwise direction. All right, so here we go. We're going to start off just by plotting points. And so the first one, the coordinates are 2 and pi over 6. And so 2 tells us how many circles to move out from the pole. All right, so I'm going to start at the middle. I'm going to move out 2 circles. And then theta tells us the angle to rotate to. And so we would rotate to the angle, 2 circles out, we rotate to the angle pi over 6. So that would be our point. All right. Next one is a little more challenging because our angle is negative. So we're still going to rotate. We're going to go out 3 circles. So from the pole, we're going to move out 3 circles to that circle right there. And then we're going to rotate the angle negative 2 pi over 3. So positive 2 pi over 3 rotates there. But we are going to rotate that same amount, but in the opposite direction. So it should take us to that one. So 3 circles out to that angle would be that point right there. Now, some people see that right away and don't have a problem with it. Some people get a little confused. So you can still, like you counted on the rectangles, you can still count on the circles. And so to rotate from 0 to 2 pi over 3, that's 1, 2, 3, 4, 5 lines. And so that's the same thing we would do here. So we would go out 3 circles to this circle right here, and then we would rotate that same amount. 1, 2, 3, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, and it would take us to that one. All right, so we can still count. If you can't see it right away, it's okay. All right, let's look at the next one. So the next one, this time our R value is negative. So instead of moving 4 circles that direction, we're actually going to move 4 circles to the left. So 1, 2, 3, 4. We're going to start there and then do our rotation from there. So rotating pi over 3 from 0 is that much, but we are rotating it actually from pi. So it's that same amount of rotation, just from a different point, not from 0. But whoops, I put it in the wrong place. Make sure we go 4 circles out. All right. And again, if you wanted to count, you can. To rotate pi over 3, it's 1, 2, 3 lines. So we would rotate that from pi, 1, 2, 3 lines. And then D is probably the most difficult because they are both negative. And so we're going to move out 3 circles to the left, so to that circle. And then we would rotate 3 pi over 4, which would be this. Whoops. It would be this amount of rotation, but we're rotating it from pi, and we're rotating it in the negative direction. So that same amount of rotation, but in the negative direction, is going to take us to here. So 3 circles out to there, be that one, right? And again, if you wanted to count, it's still going to work. So counting, to rotate 3 pi over 4, it's 1, 2, 3, 4, 5, 6, right? So what we'll do is just rotate that from pi in the clockwise direction. 1, 2, 3, 4, 5, 6. All right. And the only thing that makes this a little bit more difficult is because we have that square root, but it's okay. We can find the square root of 2 and multiply that by 3, and that's going to be approximately 4.24. So about almost 4 1/4. That's okay. We're going to rotate out 4 1/4 circles. So 1, 2, 3, 4, and a little bit more. And then we're going to rotate to the angle pi over 3. Should be about right there. Okay, so that is plotting polar coordinates. Right, and the other thing we're going to do today is convert. So we're going to go from polar coordinates to rectangular coordinates. So rectangular coordinates are what we're used to. So rectangular coordinates use x and y. So we're going to go from r and thetas to x's and y's. And so what you guys need to remember is that x is going to be equal to r cosine of theta. And y is going to be equal to r sine of theta. Now, the reason we learned this right after we learned vectors is because that is exactly how we found vectors. So if we were given the magnitude, which is kind of like r, and the direction angle, which is like theta, we could find our vector. So the horizontal component was always the magnitude times the cosine of theta, and the vertical is always the magnitude times the sine of theta. So same exact rules. All right, so let's do this. So on example 2, we have polar coordinates, we have r and theta, and we're going to change to x's and y's. So I know to find x, I'm going to take my r, and we're going to multiply it by the cosine of theta. Now to find the cosine of theta, the cosine of pi over 2 I know is a quadrant angle, and that ordered pair is 0, 1. So if I want to find the cosine at that point, I would just use the x coordinate, which is 0. So our x coordinate for our point is 0. 0 times 4 is 0. All right, and then for the y, it's going to be r times the sine of that angle. The sine of pi over 2 is going to be 1. So our y coordinate is the point, is the value of 4. So our ordered pair is in rectangular coordinates, our x and our y is the point 0, 4. And that makes sense, or it does to me anyway. If we looked back at these, if we went out 4 circles and then went to the angle pi over 4, it would be this point right here, which is like over 0 up 4. So it's that same exact point that we just wrote. All right, let's do another one. So let's see. For b, x is going to be equal to r times the cosine of theta, negative pi over 6. Okay, so one thing to remember about the cosine is that it's an even function. And for even functions, The cosine of negative pi over 6 is going to be exactly the same as the cosine of pi over 6. And to find the cosine of pi over 6, we use the pi over 6 finger, and it's the square root of the top over 2. So that x-coordinate is going to be the square root of 3. Okay. Now, something to remember about sine is an odd function. And when you have an odd function, the sine of negative pi over 6 is the same as the negative sine of positive pi over 6. So that negative drops out in the front. These are pi over 6 finger. It's going to be the square root of bottom fingers over 2. So our y is going to be -1. So our coordinate, I'm running out of room, our coordinate in rectangular form is square root of 3, -1. Okay, and then one more for C. X is going to be equal to R times the cosine of theta. Okay, so for 2 pi over 3, we are going to use our pi over 3 finger. 2 pi over 3 is in quadrant 2. And in quadrant 2, cosine is negative. And we'll do the top, square root of the top over 2. So our x coordinate is going to be 3/2. Right, and then the y. All right, sine is positive in quadrant 2, and so we'll do the square root of the bottom over 2. So our y coordinate is -3 square root of 3 over 2. So that is our ordered pair in rectangular coordinates. So that is how you go from polar to rectangular. Okay, we're going to stop there for today, and then tomorrow we'll go the other way from rectangular to polar.